Good day, everyone. Today, I want us to look at trigonometric identities. When we talk about trigonometric identities, they are like relations, they are like equations, but we use them to simplify or to solve trigonometric functions. But these are the basic ones you need to understand first before ever you'll be able to be comfortable in subsequent harder ones. We have three cases here I want us to prove. Sine square theta plus cos square theta is equal to 1. Tan theta is always equal to sine theta over cos theta. And cot theta is equal to cos theta over sine theta. Mind you, the theta you see could be replaced by any other symbol that can represent an angle, like sine square alpha plus cos square alpha is equal to 1. Sine square any angle plus cos square the same angle is equal to 1. Tan of any angle equal to sine of the same angle over cosine of the same angle. So let's see how we prove these identities. Okay, now let's start with the first one. We want to prove that sine square theta plus cos square theta is equal to 1. Actually, in mathematics, we have different ways we can approach a particular relation to prove. But I just want to go with the simplest of them all. That is using a right angle triangle. Remember, sine, cosine, and tangent, you can only discuss them in a right angle triangle. Basically, these three ratios, sine, cosine, and tangent. So because of this one represent is coming from a right angle triangle, let's use a right angle triangle to prove the first one. Okay, let's say here is a right angle triangle. Remember, what do we understand by a right angle triangle? Right angle triangle. When we say right angle, we mean 90 degrees. When the angle is exactly 90 degrees, we say right angle. What do we understand by a triangle? A three-sided figure. When the shape has only three sides or three angles, we say it's a right angle. So why the combination of the two? Right angle triangle. Because it's a triangle in which one of its interior angles is exactly 90 degrees. So we can use a right angle triangle to prove this identity. Now you have the right to choose that let here be x and let here be y. Another student could say what? A, B. Or even today saying x, y. Some other time you want to prove it, you can say A, B. You can say M, N. You can say whatsoever you want. Yeah. So here, let's say here is Z. You can also choose to say what? A, B, C or A, B, C, X, Y, Z because we just want to prove something here. Yes, you can even say P, Q, R, whatsoever. So we want to prove this identity. Okay, so what do we do? Let's choose a particular angle. So I want to say, let here be theta. I cannot say alpha again, despite we can have any symbol here to represent the angle. But the fact that what we are given here is in theta, we just have to use theta. So if the question paper says, or the question simply says, sine square alpha plus cos square alpha is equal to 1, you just have to say alpha as your given angle. All right. So what next do we do? Remember, this is the second lesson. In our previous lesson 1, suppose you've not seen that, search for it. Trigonometry lesson 1, basic trigonometric ratios. This is the second lesson. So in our previous video of lesson 1, we learned how to determine the ratios of sine, cosine, and tangent. Okay, so we learned that sine of any angle is equal to opposite over hypotenuse. Yeah, cosine of any angle is equal to adjacent over hypotenuse. Then the last one is tan of any angle is equal to opposite over what? Adjacent. So in our previous video that I labeled lesson 1, you'll be able to understand all these ones and how you can remember them. Okay, so opposite is the side that is facing the given angle. Our given angle is theta. So the side that is facing the given angle or opposite it is what we refer to as the opposite. So therefore, y is our opposite. In this case, another teacher, another student, or your very self can even choose to say, let here be what the theta or the given angle. But remember, the opposite and the adjacent sides can only be determined depending what the position of the given angle. All right. So what is our hypotenuse? Our hypotenuse is always the side facing or opposite the right angle, the 90 degrees. So this side is our hypotenuse side. Here is the hypotenuse side. And finally, the adjacent is the side between the given angle and the 90 degrees. So here is the adjacent. Yes, of all 1, 2, 3, 4, 5, 6, we have only 3 different words. That is the opposite, the one opposite to the given angle, the hypotenuse side, the one opposite to the 90 degrees, and the adjacent between the given angle and the 90 degrees. All right. So the question is to prove that this side is equal to 1. Now, sine square theta plus cos square theta is equal to 1. Proving an identity, there are 3 ways we do it. 1, consider the left-hand side, simplify it in order to get what is on the right-hand side. The second way, consider the right-hand side, simplify it, do every mathematics manipulation in order to get what is on the other side. The third way is that we solve the 2 sides simultaneously until we are able to see the same thing on both sides. Okay, so here, considering 1 on the right hand side, I'm not saying it's not possible in mathematics because we have over 1,000 trigonometric identities. Over, not even 1,000, but over 1,000 trigonometric identities. But for basic mathematics or for fundamental cases, we have very, very limited number. Very, very. So don't be scared about the number I just mentioned. Okay. So it seems impossible using 1 in order to get this one. It seems, but it is possible. So what we do is, let's consider the left-hand side. So we say, from left-hand side, using LHS is recognized worldwide for representing what? Left-hand side. So what is on the left is sine square theta plus cos square theta. But in trigonometry, sine square theta is the same as sine theta all to the power of 2 plus cos square theta is the same as cos theta to the power of 2. So conversely, sine theta to the power of 2 is the same as sine square theta. Cos theta to the power of 2 is the same as cos square theta, except if it is specifically written this way. So this is different from this one. Okay. So what next we do, let's go for sine. Sine of any angle is opposite over hypotenuse. So sine of the angle is opposite over hypotenuse according to the ratio. Opposite is y and the hypotenuse is z. So there is a square. Cos. Cosine of any angle is adjacent over hypotenuse. The adjacent is x and the hypotenuse is z. All right. So now we are no longer in trigonometry, but rather what? In indices. So this square affects the numerator and the denominator. So we say y squared over z squared. And here, x squared over z squared. Yes. So now where do we go now? We go to fractions. So remember the denominators are the same. So we take one of the denominators. So whenever you are adding fractions of the same denominator, you don't need to say this into this into that. So now that we've taken one of the denominators as the LCM, we'll simply consider the top. So y squared plus x squared. Remember what I said earlier, that proving an identity, we have three ways. One, we consider the left-hand side as we've just considered, simplifying it, manipulating whatsoever means mathematically in order to get what we have on the right-hand side. So our aim, our target is to get 1. All right. The second way is take the right-hand side, simplify it using any mathematics manipulation so far in order to get the left. Or the final one, the third one, is solve the two sides simultaneously, keep going until you are able to see the same thing on both sides. What approach we are dealing with here? We consider the left hand side, we are manipulating, we are simplifying, and our target is to get 1. All right, so we go. I think we are okay with this. Okay, so now y squared plus x squared. Y squared plus x squared. This is a right angle triangle. This one is a right angle triangle. So in a right angle triangle, we can also apply what we call Pythagoras theorem. Pythagoras theorem. What Pythagoras theorem is? In a Pythagoras theorem principle or rule, we don't have anything like opposite, we don't have anything like adjacent. We only have what we call the hypotenuse side. So what Pythagoras says, it says the square on the hypotenuse side, the hypotenuse is z. The square on the hypotenuse side, you see, the square on the hypotenuse side, the hypotenuse is z, is equal to the sum of the squares of the remaining two sides. I go again. Pythagoras theorem states that, Pythagoras rule states that the square of the hypotenuse side, which is z, is equal to the sum of the squares of the remaining two sides. So if we've written down, we have considered the hypotenuse side, the remaining two sides are y and x. Any of the two you write first, it is okay. You are correct. We want to do something here where y comes before x. So we can rather say what? Y squared, x squared. Do not forget what I just said. The square on the hypotenuse side is equal to the sum of the squares of the remaining two sides. That is Pythagoras theorem for you. So in that case, this is the point we stopped before considering Pythagoras theorem. So what does that imply? It implies that y squared plus x squared, y squared plus x squared is z squared. What is y squared plus x squared? Y squared plus x squared is z squared. So we say z squared. Why just z squared? Because y squared plus x squared is just z squared. So we divide by z squared. So in a situation wherein the denominator is not 0, in a situation wherein the denominator is not 0, whenever you divide a number by the same number, the result will always give us 1. So this divided by this will give us 1. So this one proves that sine square theta plus cos square theta is equal to 1. All the time, always. You go to any part of the world, sine square alpha plus cos square alpha is equal to 1. You are in Africa, you are in Asia, you are in Europe, you are in America, wherever on earth, this is always equal to 1. But remember, when there are no squares, this is not equal to 1. The case is different. So now let's go to the second one. We are done with the first. The second one. So now we want to prove that tan theta is equal to sine theta over cos theta. Okay. Before I started proving the first identity, I made mention that in mathematics, we have different approaches. Yeah. So I only want to deal with 2 here today. Please, those that are interested in taking down notes, you can pause the video, then you take the notes. So the reason I just give a space, you pause the video, then you can have enough space to copy. All right. because I will have to erase to have more space. Okay. Now I want to deal with two approaches here. One using the right angle triangle, the second one using what? The first one. This is the primary. One thing I like about this identity, of all the identities so far we've ever experienced, all of them are coming from this. That is the truth, the fact about it. All the identities you ever know can be generated from this. It all depends how many steps you are going to cover. Now, let me do this one using the right angle triangle. So let me call this one method 1. Okay. Now, what do we do? Let's consider, I like writing from because it has less number of word alphabet. Yeah. So from the right hand side, see, intentionally, I want to use the right hand side in order to get what? The left hand side. Yeah. Okay. So from the right hand side, on the right hand side, we have sine theta over cos theta. Okay. But what is sine? Sine is opposite over hypotenuse, SOH. SOH, CAH, TOA. We used to call this one SOHCAHTOA. Sine is opposite over hypotenuse. So sine is opposite over hypotenuse. So what about cos? Cos is adjacent over hypotenuse. Cos, adjacent over hypotenuse. Adjacent x over hypotenuse. So this is equal to the numerator y over z divide by x over z. So this tells us that y over z multiply. Remember, in fractions, we change this one to multiplication, then we consider the reciprocal. Yeah, the inverse. So the inverse of x over z is z over x. So this takes away this. Y times the remaining one is y. 1 times x is x. Yeah. But what do we want to prove? We want to prove that tan theta is equal to sine over cos. Remember, I just want to keep repeating this one. Proving an identity, you can consider the left-hand side, manipulate it mathematically in order to see this one. The other way is consider the right-hand side, the one we considered, manipulate it in order to get the left. Now, how can this be our left? Let's take a look at this one. How can this result of the right becomes the left? Now, what is tan? What is tan? Tan is opposite over adjacent. Opposite over adjacent. What is tan? Opposite over adjacent. Opposite, which is y. Opposite over adjacent, which is x. You see? So y over x is what? So we can say this one implies tan theta. So this is the first method I dealt with. I decided to do using the right angle triangle. Now let's go to the second method. How do we prove this one using the first identity here? Yes, I used to call this one the chief identity. Yeah, it is the most paramount. You can get all the remaining identities using this one. So let's go. Okay, so now how do we use so this is now our second method. How do we use this one to prove that tan is this over this? Okay, now what do we do? Ask yourself, tan is equal to what? Tan is equal to sine over cos. The question is, what is the denominator? The denominator is cos. The denominator is what? The denominator is cos. So we use cos to divide throughout. So we say cos theta, cos theta, cos theta. But we cannot simply use cos, simply because there are squares here. There is a square, there is a square, there is a square. Remember, 1 squared is 1. So we say cos square theta is what? So to do that, ask yourself, the denominator is cos, so we use what? Cos square theta everywhere. So sine over cos, it is very simple here now. What is sine over cos? It's tan. And in the previous video, I dealt with all those cases of sine, tan, and tan square theta. Yeah, cot and cot square theta. So if tan is sine over cos, then sine square over cos square is supposed to be tan square. This is what we have. Plus, what is cos over cos? Cos over cos is what? Is 1, which is 1 over cos square theta. So now we say tan square theta is equal to, on the right hand side, we have 1 over cos square theta. We move this to the other side, minus 1. We can simply give it 1. Okay, so we say tan square theta is equal to, what is the LCM of cos square theta and 1? It is cos square theta. So cos square theta into cos square theta is 1. 1 times this one is 1. Here is a minus sign. 1 into cos square theta is cos square theta. Cos square theta times 1 is cos square theta. Okay. Now let's take a look at this. If it is understood that sine square theta plus cos square theta is equal to 1, there are two cases we can generate here. Holding on to sine square will give us 1 here. This moves to the other side, minus cos square. Then again, what if this is what we hold on this time? We say cos square theta is equal to, this is 1 again. This is the one that moves to the other side, minus sine square theta. So if we are at a point wherein we have tan square theta is equal to, what is 1 minus cos square theta? 1 minus cos square theta is what? Sine square theta. So this 1 minus cos square theta, 1 minus cos square theta is what? Sine square theta. So if now we see 1 minus cos square theta, we say sine square theta over cos square theta. Yeah, sometimes your teacher can even ask you to prove that tan square theta is equal to sine square theta over cos square theta. So in that case, this is your final answer. But what we want to prove is tan theta is equal to sine over cos. So there are no squares. So what do? Remember, I made mention of this point I want to make now. Tan square theta is the same as tan theta all squared. This and this is the same as sine theta all squared cos theta all squared. So now we say tan theta with a square, there is a square, there is a square. So we say sine theta over cos theta. All of them are affected by a square. So now we go to exponential equations, wherein one term equals to one term and the powers are the same. So this takes away this. So we have tan theta is equal to sine theta over what? Cos theta. So this is a very interesting topic, which is trigonometric identities. So we've proved that tan theta is equal to sine over cos. If it were like tan square theta equal to sine square over cos square, this would have been our what? Our result. So this is what we get. Now let's go to the last one. So if you want to copy, make sure you pause the video, then you can take down the. Okay. Now let's go to the third one. The third one says, prove that cot theta is cos theta over sine theta. Okay. There are also two ways we can do this, just like I did for tan. There are also two ways we can do it, just like we did for tan. So let's say the first approach as the first method, using what? The right angle triangle. But I just want to leave the right angle triangle. You can try it and see if you can get this one. Or never mind, let's do the same. Earlier on, I had a triangle like this with theta here. What did I say here? Z. Okay, here was X, Y. So this opposite, this is the opposite. This is the one facing the 90 is the hypotenuse. And between the given angle and 90 is the adjacent. All right. So we want to prove that this is equal to this. The left is equal to the right. So what do? We consider the right hand side. Right hand side. On the right, we have sine theta over cos theta. So what does that imply? What is sine? Sine is opposite over hypotenuse. Remember, so sine is opposite over hypotenuse. Opposite over hypotenuse. So y over z. So y over z. How about cos? Cos is coming from C-A-H. Cos is adjacent over hypotenuse. See? Cos is adjacent over hypotenuse. So the adjacent is x, the hypotenuse is z. So x over z. So x over z. So this implies y over z. There is a division line here represented by this x over z. So now y over z multiplied by the inverse z over x. So this takes away this. We are left with y over x. So how is y over x? The right hand side is this one we considered. So this one gives this. So how is this now equal to this? So let's go for what? Cot. But cot is not among the three basic trigonometric ratios. But cot is what? Cot is how do I call it? It's one of the inverses. Cot is the inverse of tan. Cos is what? The inverse of tan. So now the right hand side gives this one. So let's consider the left. So from the left hand side. So the left hand side says cot theta is 1 over tan theta. In our previous video, I labeled lesson 1. Go there, you will see what the inverse trigonometric ratios, where I said the inverse of tan is cot, the inverse of sine is cosec, the inverse of cos is sec. Okay, so 1 over tan can be written as 1 divided by tan. Very simple. 1 over tan can be written this way. So 1 divided by tan. Tan is coming from TOA, TOA. Tan is opposite over adjacent. The opposite is y over the adjacent x. Okay. So we say 1. We change this one to multiplication. Then we consider the inverse. So 1 times x is x over y. So how do you compare the two? When we consider the right hand side, we get y over x. When we consider the left hand side, we get y over x. So this one shows that cot theta is actually equal to cos theta over what? Sine theta. So this is the one approach. Let's consider the second approach again. Okay. I don't want to erase this because we may need it later. Okay, let me just try to squeeze here. Yeah, we may need it later. Okay, so the second approach is using the fundamental trigonometric ratio, that is sine square theta plus cos square theta is equal to 1. But the case is, we want to show that cot is equal to this. Cot is equal to this. Ask yourself this question. What is actually the denominator here? The denominator is sine. So if the denominator is sine and there are squares everywhere, so we divide every term by sine square. If the denominator is cos, we divide throughout by cos square. So if the denominator is sine here, so we divide every term by sine square theta, sine square theta, sine square theta. So division of the same values will always give us 1 plus cos over sine. Cos over sine is cot. And if there are squares, there must be cot square. The simple cos over sine is cot. So cos square over sine square is cot square. So we say cot square theta equal to 1 over sine square theta. So now this is what we want on the left. So we write this one. Cot square theta equal to 1 over sine square theta. We move this to the other side and we give it 1. So cot square theta is equal to, the LCM here is sine square theta. The LCM of any value with 1 is always that value. So let's do that one. So this into the same thing is 1. 1 times this one is 1. There is a minus sign. 1 into this is sine square theta. Sine square theta times 1, sine square theta. So we say cot square theta is equal to, but what is 1 minus sine square? Now, if we know that, okay, if we know that sine square theta plus cos square theta is equal to 1. Now, we want to know what exactly is 1 minus sine square theta equal to. Well, if you hold on to this and write cos square theta equals to, there will be 1 on the right hand side, then you move this to the other side to become minus. So it tells us that for 1 minus sine square theta, 1 minus sine square theta is equal to what? Cos square theta. So we say cos square theta over sine square theta. Okay. So if the question were like this, cot square theta, and sorry, to prove that cot square theta is equal to cos square over sine square, this would have been our result. But the question is to show that cot is equal to cos over sine. So this can be written as cot theta all squared, and there is a square, there is a square. So we say cos theta over sine theta all squared. So from exponential equations, we are in one term equals to one term, and the powers are the same. We can simply cancel them. So we say cot theta is actually equal to cos theta over what? Sine theta. So you can see that we have proved what we are given. So please don't forget to like, to share, and comment. And also don't forget to follow. Thank you.